So what was the first question? Was how long until she hits the water? Was it?
Yeah.
Also, with her maximum height.
And her maximum height as well. Ah, okay. So how did we do on the maximum height? Did we get that answer?
Yeah.
Yeah.
It's too small for me.
No, it should be small because she's only jumping
Yeah, well,
3.325 meters.
from the water.
Yeah.
And how high up is the diving board?
it's 3. It was 3.
It was 3, and then the
Yeah,
time
3
is
meters.
1.33 seconds.
Oh, so the maximum height is 3.25, is it?
Yeah.
Okay, no, that's not that big. But it's just the numbers I made up then. Did you get the same maximum height?
Let's run through that, please.
Yes, okay, alright. So, I just need to get the information off of you once my pen turns on. Dude, English.
Sorry.
What's up? Right. My clock is totally wrong. Okay, so what do we know? She's on a diving board
That's 3 meters.
and it's 3 meters above the water. Okay, and then she jumps off at some angle, yeah?
But when we start it works fast because the electrons are already in the wire.
You're still on it.
Yeah, I think so.
What are you asking me?
I read it somewhere. Like, as soon as we started, this works.
Yeah?
But if the electrons were slow, why did it work as soon as we started? And the answer is because this...
The electrons are moving slow, but they move immediately. So although they're moving slow...
No, but I mean, like, because there is, like, some...
Okay, look. Just 30 seconds is all you're going to get, okay? So this is the wire here, and it's full of the electrons, but it's completely full of the electrons. So when you turn the switch on, the electrons start to move.
At the beginning.
Yeah,
They get pushed.
but they all move together very slowly. So although they move slowly, these ones here don't have far to travel, and this is why it turns on quickly.
Yeah.
If they were moving slowly and it started back here, then you'll have to wait, like 60 seconds until they reach the end of the wire. Their speed is quite slow. They're, you're talking about a speed of like 1 centimeter per second is their speed, the electrons.
I thought that's cool.
Yeah, that's what everybody thinks, that the electrons are going really fast in the cable. They're not. They're going really slow. But we'll have a look at that later, okay? If you want to read more about this online, it's called electron drift. Like Tokyo drift. Electron drift. Yeah, I taught you mine. That's why I said it. So, electron drift. It's not as exciting as Tokyo drift, but you'll remember the name that way. Okay, so what angle does she launch at? 60 degrees, and her speed?
5.
So this is 5 cos 60, and this one here is 5 sin 60. Okie doke. And what do I want first? Is it the time?
Maximum height.
Maximum height first?
Yes.
Yeah. So the U is 5 sin 60. The V?
We don't know.
For maximum height?
Oh, 0, yes.
0.
Yes.
The A?
Minus
9.81. The T we don't know, and the S is what we want.
Yes.
What formula?
V squared.
V squared formula? Yeah. V squared equals U squared plus 2AS. Well, that's easy. So, what do we get here? 5 sin 60 squared over 2, 1. So, the S is 0.956 meters.
That's what I got.
Yeah.
Okay,
Make
so...
a mistake, maybe?
alright.
I think in the procedure I made some.
Okay.
Could we hold for a minute, please?
Yeah, well actually that's not is the answer the maximum height above the water? Because if it is, then you'll have to add 3 meters to it. Okay, yes?
Okay, so in question 1, of his homework, we've done the maximum height
Yeah.
as well, and I couldn't get the same number that you got when we did the class.
For which one?
It was number one was the maximum height, and the answer was 74.
Okay. Well, did you spot a mistake I made?
I don't know. I mean, maybe I really don't know. But I mean, here's
This is the video.
this is a picture of the video. I just took a screenshot.
57, 52, 52. Yeah, I see what you mean. Maybe I just did something stupid, like typed in the wrong numbers in the calculator, you know? $74.8? No, it looks right.
Okay, so how did you do it?
Alright, well, but I do this one as an example of the steps I took in my mind, yeah?
Alright.
So what I did was, I took this to the left and had 5 sine 60 with a minus.
Yeah.
But there's a minus on the right as well. So I can forget about the minus. They're gone. And then I divided by this. Now I have a feeling that maybe you're mistyping it on your calculator. So what I typed in was 5 sine 60. And then after I got the answer, I squared the answer.
Okay.
So I did it in 2 steps. And this possibly could be the reason why maybe yours is different if you try to do it in 1 step, I don't know. And I got 0.956 again. Yeah.
I got this one right.
Oh!
This one I got it right, but the first one I didn't.
Give it another go. If not, we can look at it then.
Okay.
I've done this in this way, but your answer is 3.9, mine is 3.3. There must be some.
Okay, something's going wrong. Either you or me. Do you see anything I did wrong here?
The answer is 3.95.
Yeah.
For you.
Yeah.
For me, 3.3.
Uh,
I've done this way.
You did it the same way. No, you use S equals.
First I find the time and then I find the maximum height.
Ah, this is the mistake. So that time, that's the time to go from here to here.
Yeah.
But that's not the time you would want. You'd want the time to go from here to here.
Oh.
So this is why it doesn't work then. Okay.
Why don't I get electrified when I touch a copper wire? There is electricity.
You will get electrified.
It's not that true, electricity, but still there is electricity.
Yeah. But they're not moving. It's moving electrons that will hurt you, not stationary electrons.
What's the difference?
One is moving, the other is not. Let me put it this way to you. If you touch a car that's not moving,
Okay.
or you decide to touch a car that is moving towards you, which do you think will hurt more?
The one.
Yeah, so there is a big difference when something is moving and not moving.
Yeah, but like
Yeah.
this is the car, and this is.
Doesn't matter.
This is an
It's the same analogy. It's the same concept. Okay. So you were saying, well, what's the difference if it's moving or not? And I'm saying it can be a very big difference if it's moving or not.
Because it doesn't get to me. I don't.
Yeah.
You get to me.
The electrons won't go into you if they're not moving because they're not moving.
There is no electrons on the surface.
There is, but they won't just move into you because they want to. They have to be moving. There has to be a current. Yeah.
I'm asking too much because I don't.
No. But like I said, why didn't you Google this yourself?
I Google, but I don't like Google.
YouTube then.
Yeah,
YouTube
I should
then.
have YouTube.
Okay, next is the time to hit the water.
Yeah.
So, okay, U, 5 sine 60. V, don't know. A, minus 9.81. T, we don't know, it's what we want. And the S, minus 3. So, S equals U T plus a half A T squared, so I get 4.905 T squared. Now, 5 sine 60 is 4.33. So that'll be minus 4.33 T minus 3 equals 0. Have you done the quadratic formula in
Yes.
maths class? You have?
Yes.
Good. So using the quadratic formula, we get 2 answers. The first answer is 1.34 seconds, and the second answer is negative, which doesn't make sense. Did you get that? So you got the second part, but not the first part.
No, I got the two parts correct.
Oh, good. Okay. Okay.
I've got the first one correct.
Good.
Time correct.
Good. Good. Okay. All right. Now the tricky one.
Yes.
Okay. Sorry. Can I scroll? I can scroll down. So you got it correct. You said. Andy, did you get this one?
Yeah.
Both of parts.
No, not both.
Which part did you get? What was your mistake in the second part?
I didn't. The time.
Mhm. Yeah.
Yeah.
What did you do? What did you do wrong?
I didn't get it.
Oh, you couldn't start it.
Yeah.
Okay. But you knew this.
Yeah.
But you didn't know this.
Yeah.
Okay. Is it okay now?
Yes.
You sure? Okay. Right. The last one now. So what's happening in my story? There's a cannon on top of a cliff. Is it?
Yeah. Fires the ball.
Okay. Just a sec. Let me draw a cannon. And it fires it at a pirate ship, I believe. This is all important information for solving. All right. And
The cliff is 300 meters.
what else do you know?
The cliff is 300 meters.
Oh, this is 300 meters. Okay, what else do you know?
We don't have the angle, it's theta.
Yeah.
33 and maximum speed.
You know the cannon can travel this fast. Yeah. And you probably know how far away the boat is.
Yes, 200 meters away.
Now, the reason I put this question in is because it's kind of like, a real type of physics problem in that the information you know is, if you were the person here, you have the cannon, so you know the capabilities of the cannon. You know that the speed of the ball is 33 because, it's information about the cannon. You don't have to find it. It might even say it on the cannon, the manual. Okay, so you know this. And of course, if you are positioned here defending your city, you already know the height of the cliff because that's well-known information. And what about the distance out from the boat? You can estimate it, or you can measure it by using some kind of telescope. So this is, what I'm trying to show you is that this is kind of like, although it's kind of a funny story, it's like what you have in physics normally and engineering. In engineering, this is the information that you would know, and what you would like to know is, what's the angle here? Because that's the choice you have to make. Okay?
Yeah.
So, we'll resolve. We know that this one here will be 33 cos theta, but we don't know the theta. And this here will be 33 sine theta. So let's put down the information that we do know. Horizontally, we have u, v, a, t, s. The u is 33 cos theta. The v we don't know. The a we know is 0. The t we don't know. But the s we do know. No, horizontally. 200. Vertically, u, v, a, t, s. The u we know is 33 sine theta. The v we don't know. The a we do know, minus 9.81. The t we don't know, and the s we do know, minus 300. Okay. So let's see what equations we can make. We can use distance equals speed multiplied by time. So distance equals speed multiplied by time. And then here we have s equals u t plus a half a t squared. Now, we are looking for theta. We don't care what the time is. We just care about knowing what the theta is. Yeah? So we have two equations with two unknowns. How should we combine them?
Rearrange.
Yeah. Rearrange them. Now this time we get the t. Oops. Over 33 cos theta. And then I should put that in here. So now I get minus 300 equals 33 sine theta times 200 over 33 cos theta minus 4.905 t squared. So I can clean that up. Now I don't know, yeah?
You can put the t squared, the value of t in t squared.
Oh sorry, did I not put in the t? Alright, why did I not do that? That's silly. Sorry, t squared of course, which is 200 over 33 cos theta. Okay, so let's do some cleaning up. Thank goodness. Right, let's do some cleaning up. So here, 200 divided by 33. Oh, well actually, look what happens here.
Yeah.
They cancel. So we have minus 300. Now, does anyone know what sine divided by cos is?
Tan.
It's tan actually, but you don't need to know that just yet. So that's sine theta over cos theta. And here, 200 squared divided by 33 squared times 4.905. This will be minus 108.17 over cos squared theta. Yeah?
Yeah.
Now, I explicitly said in the question, do not solve this one. Oh, rats, open the wrong program. But this can be solved, but it's a little bit too advanced for you to solve right now. Okay? What I'll do is I'll just clean it up a little bit. What would be the easiest way to clean this up? I'll multiply everything by cos squared theta. Okay? So here I get minus 300 cos squared theta. That equals, now when I have cos squared over cos, what happens? No, cos squared over cos.
Then
You're left with just cos, yeah. So cos by sine. So, oops. Come on. Sine theta. Oh well, look, if that's confusing, just forget about it. I don't even need to do that one. So if I solve this equation, I know what the theta is. Okay? And that's what I'm going to do. But remember I said it's a little bit too difficult to solve. So we can solve it using Excel. Can you just write this down and then we'll type it into Excel. I'll show you what I mean by solving it in Excel. So how far did you get when you tried this?
I haven't even.
Not even close?
I had a look at it and it was so scary.
Well, still, I stopped at the rearrangement at the time.
So you actually made it to here?
Yes.
Okay. And what made you stop?
I got
You
scared.
yeah. Andy,
Yeah.
what happened for you then?
I didn't care.
Could you start it?
Yeah.
How far did you get? I mean, for example, were you able to write this down?
Yeah, I read this book.
Okay. Yeah. Yes, yes. Now, good news, you can walk behind me. You don't need to step over that. Did you write the equation down at the end?
No.
Yeah. You can get by? Yeah. Why don't you turn the lock so that you can come back in? Yeah. Keep going. Got it? Good. No, that's fine. Yeah. Yeah. Okay, I need to push on. Do we have this nearly?
You can.
Well, let me just show you the Excel part. So let me just type in this equation. Let me just double check something. So this is the angle, and the only thing I'll change slightly here, guys, just look. I'll just bring this 300 to the right. Okay, so if I bring the 300 to the right, what happens? It becomes plus. So I'll just have it as 0 equals 300 plus this. I just moved the 300 over. Okay. So, let's say 0. Oh, come on. I just want to check something here. Yeah. Right, so my formula, what was it? It was 300 plus sine theta over cos theta sine theta over cos theta, and what's next? Minus 180.17 divided by, and then there's a cos squared. I hope this works. Okay, great. Can we see this? I'll make it a bit larger. So what I've done is I've typed in the angle, and then I asked Excel to calculate the value of this. Now what do we want this to equal? We want it to be 0. Yeah, well, I typed this into Excel, and I basically asked Excel to calculate this for different values of theta. So I started with theta as 0, and do I get 0? No. So let's see what happens if I increase the angle. It's a little better. So what am I trying to get? I'm trying to get 0. Then I found the solution. In other words, I'm just guessing. I'm trying different angles until I find one that works. Now, I'm getting closer to 0, haven't I?
Yeah.
Oh, no, I've gone too far. So, somewhere around about between 39 and 40. You can't see it. Here it's positive, and here the answer is negative. So the zeros must have happened in between. So if I'm just using Excel, I can estimate that the angle that solves this equation is probably about 39.5 degrees. This is the angle to launch at, okay? Now you'll actually do something like this in maths class where the equation that you have is too difficult to solve, so you use some kind of process to try and find the solution roughly. Okay? But like I said, that's not part of physics today. I just wanted to show you, if you have an equation that's too difficult to solve, you can always solve it by just trying different values until you find the one that works. Does anyone know the name of this approach in maths? If you do problems this way? No? It's called numerical methods. Numerical meaning number, you're trying different numbers. It's a number approach. Have you heard of this before, numerical methods?
Number and series, we have studied number and series.
Yeah, not stuff like this. You see, a lot of places don't do it. You'll do it in semester 2 in maths. Okay, can we move on now?
Yeah.
Yep. I'll give you 10 seconds. Is that going to be enough time?
Like you have written 0 is equals to 300, it's plus or not?
Plus, that's a plus, yeah. I just moved it over. Is that good? Okay. Okay, can we continue? We'll continue? Okay, that's